Hello, everybody. This is our video for 3-6, generate equivalent expressions. And I have a couple problems here from our homework. And we're just going to briefly go over what we went over today in class. So when thinking about equivalent expressions, we're looking at it being the same as the other one. They haven't changed their value at all. They just look a little different. So here we have a problem with the distributive property. So I told the class when they see parentheses like this, I want them to think about multiplication. So parentheses indicate multiplication. So I'm going to use this outside value and multiply it into each term. Okay, so I told them, and I told you guys, to draw an arrow until it becomes natural to not do so. So the first thing I'm going to do is I'm going to multiply this term, 8 times 2y. So if you have a hard time with the decimal, I would say the variable, I'd say just ignore this variable and focus on the number. 8 times 2 is 16. Then deal with the y. So I know that 8 times 2 is 16, and this y is clumped on it, so we're going to stick it together. So we have 18y. Then we're going to go to the next term, 8 times 1/4. I know a lot of you get scared when you see fractions, but you know how to do this. I have a whole number 8 times 1/4. And the way to multiply with a whole number is to make it a fraction by putting it over 1. So I can go ahead and just multiply the numerators, which is 8, and the denominators, which is 4, and I can read it as a fraction. 8 divided by 4 is 2. Okay, so my answer, my equivalent expression, because I'm not solving for anything, is 18y plus 2. The other way to think about your fraction, if you're not someone who wants to multiply, is you can use a tape diagram. Okay, so I'm going to do one hole right here and another hole right here, and I'm going to cut them into fourths. Okay, so it tells me I have fourths and I have 8 of them. So 1, 2, 3, 4, 5, 6, 7, 8. How much does that come out to if I have 8 1/4? 1 plus 1, which is 2. So that's another way to look at it. Okay. Don't let fractions scare you. There are several ways to go about them. You can use multiplication, or you can use a model to help figure it out. Okay. Now, another problem that we looked at was not multiplying with the distributive property, but factoring out some numbers to make an equivalent expression. So looking at both of these terms here, I want to try and figure out what number do they both have in common. So I'm looking for their greatest common factor, which we practice using prime factorization. So what number can be multiplied into both of these? So I'm just going to do a quick factor tree here. Oops, 2 times 2. And this one is 2 times 1. What's the biggest number they have in common? 2. So I know that I'm going to pull out or factor out a 2. Then I'll do my parentheses and write my operator. Okay. Now I'm going to look at this 2 and I'm going to say, what do I multiply by 2 to make it look like 2x? Well, I know I have to multiply it by an x, and then it would be 2x, just like that. Now I'm going to go to the next space and I'm going to say 2 times what makes it look like 4y. Again, if the variable gives you trouble, just start by looking at the number here. So 2 times what equals 4? I know that 2 times 2 equals 4, but it has that y variable, so I'm going to go ahead and add that in there. So my answer, my equivalent expression, is 2 times the quantity of x plus 2y. These two expressions are the same thing. Okay? Next one here, we have another one that's a little bit more, it's not as doable because the number is going to be different than 2. So let's say we wanted to find the GCF using prime factorization. Just a little review from before. We're going to did not mean to use a marker there. We're going to prime factor just like we did before. So I'll start with 16. I'll do 8 and 2. And remember to circle the factors that are prime. 8 is not prime, so we're going to keep factoring it. And that's 4 times 2. 4 is not prime, so we're going to keep factoring until we have all prime numbers. So 16 is the same as 2 times 2 times 2 times 2. Okay, now let's do 12. We'll do 3 and 4. 3 is prime, but 4 is not. And our 2's are prime. So this is the same as 3, 2, and 2. Now, both of our lists, we're going to find the GCF. We are going to see which ones they have in common. Okay, and I see that they have 1, 2. So I'll write that 2 down. And they have another 2 in common. They don't have a 3 or any more 2's. So I can see that their greatest common factor is 4. So when I'm going to do my problem now, I know that I'm going to factor out a 4. And then I'll put my parentheses in my operating sign. Okay, and now I'm going to look at 4, and I'll say, okay, 4 times what looks like 12x? Or again, if that variable messes you up, 4 times what equals 12? Well, 4 times 3 equals 12, and then we can just add in our x. Okay, same thing over here. 4 times what equals 16? 4. And that's it, guys. That's our equivalent expression. Okay, so we're using skills that we previously learned. If you can't think of the factor right off the top of your head, use a skill that we've already learned to figure it out. Okay, that is all I have for you. I do want to note that if you are one of my Math 6 classes, you do have a chart where it looks like we have x, and then we have 3 separate columns here. Okay, and then our x values are 1, 2, and 3, and then we have some problems like 12x minus 6, 6 times the quantity of 2x minus 1, and 6 times the quantity, oops, that was the last one. Let me get that out of there. Okay, the middle one is 3x plus 3, and then 6 times the quantity of 2x minus 1. Okay, so this one is number 9 in our book. This one is just what we practiced on our scavenger hunt. Okay, we have an algebraic expression and then an x value. So we're going to end up doing this problem 3 separate times. So for this one, I'm going to insert 1 as my x value and solve for it. In this column, I'm going to put 2 as my x value and solve, and so forth. So let's go ahead and do the x value for this column. So I have 6 times the quantity of 2, and then I have an x right there, so I'm going to put in a 2 in its place. So 2 times 2 is 4. 4 minus 1 is 3. And then 6 times 3 is 18. So my answer in that box would be 18. Now let's try this one again. Well, this one we're going to put a 3 because we're in the 3 column. 2 times 3 is 6 minus 1. 6 minus 1 is 5. And 6 times 5 is 30. So that box is going to be worth 30. Okay, so these ones are just practicing that skill that we did with the scavenger hunt. Okay, if you guys have any questions, please reach out to me on via email, and I'd be happy to help you out. Happy math!